We have a definite integration here, you can tell because of the boundaries which are on the integration sign. And they're using infinity as one of the boundaries. So we're just going to roll with that and rearrange what it looks like so we can do the integration. We're going to take the x squared, which is on the denominator, bring it to the numerator by using the index law where we can make the power negative. And when it looks like that, then it becomes a whole lot easier. So it's integration, remember, not differentiation. For integration, we add 1 to the power, so negative 2 becomes negative 1. And then we divide the coefficient by the new power. So we're dividing 2 by negative 1 and it turns into negative 2. The boundaries stay the same, 3 to infinity. Now, when you do the integration, you get rid of the integration sign and we introduce these square bracket signs. That's important. All right, so now we substitute the boundaries. We're going to put infinity in first and we'll have negative 2. Let's put it back over infinity because x to the negative 1 means x is on the denominator. So let's put it on the bottom of the fraction. And then we subtract and put in brackets so we don't make a mistake at any point. Negative 2 divided by 3, which is the other boundary. Okay, so the thinking part here is what happens when you divide by infinity? Well, technically you can't because infinity is not really a number. But as numbers get larger and larger and larger, and which are on the denominator of a fraction, then the whole fraction gets smaller and smaller and smaller. And so if we could get to infinity, then the fraction would get to 0. I hope you can see that that is what would happen. And so the first term there just turns into 0. And then we have minus and negative, which turns into a positive. 2/3, and that is our answer.